Hi everybody, welcome to the Manifold channel. Today we're going to take a look at some really big news. Manifold has added GPU parallelism to the Manifold viewer. Let's take a look at viewer. We're looking at viewer right now, and we're going to open up a file, the demo file that you can download from the Manifold website. Click File, Open, and we'll click here on the MXB file. That's a compressed archive form which reduces the size of the file, so it takes a moment to open. If it was a Release 9 file that wasn't compressed, it would open instantly. And what's the news here? Well, as you may know, Viewer is the read-only version of Manifold System Release 9, which has always been fully CPU parallel and GPU parallel. Viewer likewise has been CPU parallel, but because it's a free product, there's been a limitation on it that it hasn't had GPU parallelism like Manifold Release 9 does. That's just been removed in the most recent build, 168.8. So we're going to take a look at how that works. And what we're going to do is we're going to open up this file right here, double click on that. That's a view of terrain elevation data for the Mount Hood area in Mount Hood in Oregon. And what we're going to do is we're going to compute aspect on that. To see the sort of hardware that we're working on with here, we can click Help, click About, and you can see we're running Manifold Viewer. It's running in 64-bit mode down here. You can see that we don't have a particularly high-powered machine here. It's an AMD FX 8300 8-core processor. The AMD FX these days can be purchased on Newegg for about $85, so that's not exactly some sort of fire-breathing $1,500 Core i something or other. The GPU is a pretty cool GPU. It's a GTX 1060 with 6 GB. That's about a $240 GPU card, and prices are coming down very quickly. We only have 32 gigabytes of RAM, and we're running Windows 10. Whoops, I see we need to update. That's 1803 right there. Great. So that's what we have to work with here. It's a very average, very inexpensive machine, nothing too hot. And let's do some GPU magic. We click on the contents pane, and here I'll choose Transform. And what I'm going to do is I'm going to click on Aspect. When you click on Aspect with a radius of 1, what it'll do is it'll compute which way all these slopes are facing. A radius of 1 is an extremely easy computation. It's so easy. I'm going to click Add Component. And it's so quick that it happens virtually instantly. If I go back here to look at all the comments here, let's double click to README. Let's see, this I believe is a 3600 by 3600 pixels in size, the image. And running that created this Mount Hood tiles aspect image. So it's showing us which direction, that is north, south, east, and west in grayscale, that the terrain faces in the various elevations. Running on, and how long did that take? Click here to panes, the log window. We can see that took us, the transform took us 2 seconds. It would actually be faster if we didn't use the GPU, because this is such a tiny data set, and the computation for an aspect of 1 is so simple that we really don't get to use the GPU much. So let's do something. Let's rerun this, but let's do this in a more sophisticated way. Let's use a radius of 3. Now, a radius of 3 is something that takes ArcGIS, ArcGIS or and QGIS aren't able to do radius of 3, but if it did, it would take them a few minutes. Let's click Add Component, and you can see that happens right quick also. If you look at the log, that took 2.14 seconds. So going from a radius of 1 to a radius of 3, which is about 35 times as much work, took about 1/10 of a second. If we look at the project here, we click open the aspect image. If you looked at the more details, you'd see that it was a smoother, better computed image. Let's do this even further. Let's make that an aspect of, let's say 5, which is an enormously complicated calculation that would take. If ArcGIS could do this, or if QGIS could do a radius of 5, it would take it probably, I don't know, an hour, something like that. And here in this case, let's look at that log window again. It took us 2.6 seconds. Now, we are running with a GPU card here, which has a 1,268 processors. So when Manifold fires up a computation like this, it doesn't change much, even though it's a very formidably complicated computation. And let's get rid of these aspect images that we've been creating. If we like, we can rerun the computation And we can do that without using a GPU. To do that, let's go here to, no, I don't want to do this. I want to open up my comment here. And down here it talks about how you can turn off parallelism if you want to turn off parallelism. And this is a magic line here that we can add to the query to turn off parallelism. Anything that Manifold does here, if we want to see how it works, for example, aspect, let's say we want to see what it takes to do an aspect of, let's say with a radius of, let's do it with a radius of 1. And we allow parallel execution, so it's going to run CPU parallel. If we want to see what the query is behind all this, we just click Edit Query. And what Manifold will do is it'll open the query that's actually being executed to run the command to do that aspect. And right down here is the magic. This is where it tells Manifold, go be parallel. This is CPU parallel. It's telling it to use as many threads as there are CPUs in the system. The system CPU count function returns the number of CPUs, cores in the system. So to use that many threads, tells it to use all those threads. Now it automatically runs CPU parallel. To turn that off, we have to add a line here, and that's the one that I copied and pasted. So I'm going to add the line pragma GPU is equals none. So the pragma is the directive that tells it in terms of what GPU devices I have in there to force the use of no GPU devices. Now when we run this query, we'll compute the aspect, but we'll compute the aspect using parallel CPU only. Now Manifold's really fast running parallel, as you can see, and Vera is really fast running parallel. That's the same aspect that we computed earlier. This time, because we ran CPU parallel only, it actually ran in, well, almost no time at all. You know, it's the query, it was about 0.6 of a second. There's the value right there. For very, very tiny tasks like this, Manifold will not bother to optimize between CPU and GPU. And parallel CPU will often run faster than parallel GPU because the data is so small and the computation is so trivial. So let's look at a meteor computation. And we'll start by looking at here. There's a different project that I have up, and this is Central Europe. The Central Europe project is considerably bigger. This is 13,000 by 8,000 pixels, so it's about 110 million pixels that are involved. And this gets more interesting. If we compute this with an aspect of, with a radius of 1, let's add component. Let's click on that. Let's see how long that takes. Manifold, of course, is very fast, so even this very much larger image with an aspect of 1, view, panes, log window, we see that it took us 6.57 seconds to compute all of Europe. Let's see how long it would take QGIS to do the equivalent thing. I'll kind of give away the game. This is QGIS 3.2, the Bond thing, and what we've done is we've loaded the exact same raster that we saw in here. It's not colored, it's just simply black and white, but it's the same one. We loaded it from a TIFF file. And now we're going to use the aspect tool in QGIS to compute it. We'll just click Run in Background and see how long it takes it to run. QGIS also logs the activity, but it only logs the computation. It doesn't log the how long it takes it to create intermediate levels. So this is actually going to run considerably longer than what QGIS reports as the actual runtime. But that's okay. We'll just look at the time, and that took QGIS 16.59 seconds for the actual computation. So that's 16.59 seconds for QGIS to get a aspect which is which only uses a radius of 1. That's a 3x3 matrix. Manifold, doing the same thing, took, as we saw here in the log, 6.5 seconds. So that's roughly twice as fast. But where it gets much more interesting is, let's get rid of these aspect images we created. Let's do a really bigger computation. Let's see how long it takes us if we do it with an aspect of 3. That's 35 times larger computation. And because we're using GPU parallelism, we can do that phenomenally larger computation. And let's wait for it. Let's see how long it took that to do. Panes. That took us not 6 seconds, but it took us 8.5 seconds. So even though the computation was 35 times more challenging, it only took 2 seconds longer. That's the power. That's the magic of GPU. If we like, we could do something even crazier. Let's do an even bigger aspect computation. Let's use a radius of 5. Radius of 5 is using a matrix that's, let's see, that's 11 by 11, or 132 matrix positions. And this is something that if QGIS or ArcGIS had it, it would probably take them a couple of hours. You know, so let's see how long it takes Manifold to do this, and we'll click Add Component. I'll give the game away. This is a spoiler. It's not going to take a couple hours. In fact, it's going to take just a few seconds, not very many more seconds than it took to do the computation with. It's done already. And let's see how long that took. It took 12.9 seconds. So to do the computation with a radius of 1, it took 6 seconds. To do it with a radius of 3, it took 8.5 seconds. And to do it with a radius of 5, a massively more complicated computation than just with a radius of 1, it took it about 13 seconds. So basically, what you can see is that using Viewer, which is a free gadget, you can see Help, About, same system, same 8-core processor, same GTX, same 32 gigs, same free viewer running 64 bits. And we're doing supercomputer performance here. We're doing things in 12 seconds that would take an ordinary non-parallel, non-GPU GIS a couple of hours. So I hope you've enjoyed the presentation. It's been a lot of fun doing this. Download Viewer, and you can now use Viewer for free doing GPU stuff. You must launch Viewer in 64 bits. It won't work in 32 bits because Manifold no longer will support GPU computations in 32-bit versions. That's just kind of a, I mean, it's like supporting translations in a Sumerian or something. So run 64-bit and run Viewer in 64-bit. You must have a GPU card, an NVIDIA GPU card that's reasonable vintage. So one that's been purchased in the last few years. That's got to be Fermi or above. And any of the modern GPU cards that'll cost anywhere from, say, $40 to, you know, whatever, $200 or $300 are just perfectly fine. They'll just absolutely blow you away with the performance. So give it a try and enjoy. Thanks for watching, and goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.